Hello guys, today we are back looking at the Claas Xerion 5000. In the last video you've seen these 3D printed parts that I added, but these little sections down here, a lot of them ended up breaking, so I've reprinted them. I've made these parts a little bit stronger, so hopefully this is going to be a little bit better this time. So we're going to replace those parts and try and mount the rest of the body back on the frame that we have. So when I did this the first time, I broke this part. There was bits that weren't designed right anyway, so hopefully they're going to be working a little bit better this time and they'll be a little bit stronger. I've increased this diameter around these little joints, so hopefully they'll stay a little bit stronger. I did reprint the one for the front, but somehow it's ended up being a little bit bigger. So maybe this was an old model that I modified by accident there. So I'll have to find that one and rebuild it just to make sure that we get it to the right sizes. But that's kind of holding up okay for the minute on the front axle. It's the rear that we really need to worry about. So first things first, let's swap out the broken parts for these parts, and then we can get on to modifying that piece. These seem to be a little bit tight, so I think I'll widen these holes out slightly to let the screws in a wee bit better. And it was pushing these pins in here that I broke the little connectors with the last time, so I think I'll do that off camera so that I can kind of look at it properly. It's kind of hard to do everything around a microphone and a camera, so I'll see if I can get these things all mounted up without breaking them, and we'll see how things go then after that. Well, there's those parts on. I just put them on gently. I didn't push these pins all the way in. I just got them lined up, made sure that they were in this side as well, and just tapped them. It was just with the end of a hex, sort of a drill bit. I just tapped them in so that they were nice and snug there. They're not falling out, so that's what I want. I didn't push them in with pliers because I think what happened the last time was when you pressed it in, it didn't just go straight. Once the shaft started to slide on the bracket, the pliers kind of twisted, and just that's what's doing the damage, I think. So just got everything lined up and gently tapped it until that's probably gone in half a mil. So it's gripped it on this side. That's all that we really want, and I think that's the key to not damaging these parts really. Because it's not this resin material is not like that's probably PP or something. Like it's going to have a little bit of give in it, whereas this is going to be more brittle. If you put too much stress on it, it'll crack. Now the next part of the process is to get the body on the unit here. So I've put this hole on this side. I don't know if you can see that in the light. There's kind of like a triangular section here. It's hard to see on the screen of the camera, but basically in the center of this little triangular section here there is a hole. We'll line that up with the body when we have it on, and then I'll try and drill the hole through the chassis. On the other side there's a little mounting point here, so I took a little plastic stand off, mounted that on there. There's a nut down this side. You mightn't be able to see that, but it's just down there and tightened down. On the unit itself here, that is going to line up with the hole that you can see there. At the minute that's got the this engine in it, so I can take this screw out and I'll still be able to access that because that sticks away out the front here. So I can take the engine out and screw it in after. I can just get the screw into the standoff here first, so I'm not too worried about the front side of it. But now let's just line it up so that we can get the position of the rear mounting hole. So you can see that in there. So we have at that's lined up. It's very hard to see on the camera if you can actually see these things, but the standoff is in there, it's lined up with that hole, so that's what we want. On the back here, this needs to go down a little. Not sure, it's not just lining up perfectly, I don't think. There we go. So now that's sitting in where it's supposed to sit, and the little hole is there. So I'm going to put a drill bit in through there. I'm going to mark that hole, and then I'm going to bring this out to the shed, get it in the vice blocks, and drill the hole through there and tap it. Try not to make the hole too big that we won't be able to tap it. And that'll fix the back in. We'll take the engine out of the front. We'll get this fixed in with the standoff, and that'll be the chassis mounted in. Just 2 mounting bolts to get it on and off. That's what you want, I think. I'm going to try and get as much onto the chassis part of it as I can, so that we can just lift this part off if we need to make any changes or modify anything. So that's all looking pretty good. The other thing I decided, I think I said in the previous video I wasn't going to bother with lifting arms on this, but I kind of changed my mind when I was printing this part. What I'm going to do, I've put a cylinder through here. So I don't know if you can see that either, but there's a cylinder running along here just above our clevis hitch, and that is going to allow this part to hinge. But I'm getting rid of this toe eye here, whatever you'd call that. I'm just going to cut it off there, so that I can get a bolt through there, and my lifting arms, when they're fully lifted up, will be completely out of the way of the clevis hitch, or at least that's the plan, that they won't impede the turning of the trailers on the back. So if this works out right, we'll be pivoting here, and when we fully lift up our lifting arms, we'll be completely clear of the clevis hitch, and the trailers will be able to turn perfectly. That's the plan anyway. Might not work, but all we can do is try that. So when I'm out drilling the hole here, I'll also cut this part off. I added the hole here and tapped it, and I also added another one here to let us move the rear links up and down. So first thing I need to do is get the other components back on this, and then we can test it on here. Hopefully we'll be able to get it hooked up. So all that's left now to put on is the bonnet, but we don't want to put that on yet because we need access to this screw hole in here to mount to the chassis. I cut the centerpiece out of this, but I have no pin that's long enough to fit this section here, so for now we're just going to have to leave this out of it, unfortunately. But that's okay, because we weren't really set up for it yet anyway with a servo or anything really. So for now we'll not worry about the rear link, we'll just get our model together. So we'll line the back up here first. That's down where it's supposed to be. Hopefully the screw now will line up correctly and it'll thread in. That's a little tight, so I might just open this hole up slightly with a drill bit just. Okay, I just drilled the plastic out by hand there, nice and carefully, so that we didn't crack the 3D printed part. And now we'll just line things up again, and hopefully we'll be able to get this into position. So that's down where it's supposed to be. Hopefully the screw will line up now. Yep, looks like we got the hole to line up perfectly there. I can feel that's threaded into position. And on the other side we have the standoff. That seems to have lined up alright, so we'll get a screw for this side. Okay, so that's it down on its chassis. The last thing to do is just put the bonnet on. Well, there we have it. It's on its chassis. So all connected up there. That's our 4-wheel drive Claas Xerion. So we're missing 2 servos and LEDs. We'll have to add a steering servo and a servo for the rear links. But this is basically what it's going to be like. There's our rear links in around about where they are, and you can see it's fairly clear up the side of the, well, actually it's very hard to see with the light, but it's fairly clear on the clevis hitch. It's just everything's black. I'm not sure if it's coming out clear on the camera or not. So that's pretty much it. Let me get a control board and we'll just see how fast this is, just out of interest. Okay, so I have one of the test controllers here. This was programmed with the code for the R730, I think. So we should be able to control the speed of the motor. Yep. Well, that's full speed and it's not very fast. I think we might have to change that motor for a faster N20. I'd imagine it's got a fair bit of pulling power. Well, I might not change the motor just yet. I might see how much pulling power it has. I'd assume it's got far too much. It's probably just going to break a lot of the 3D printed parts in the drivetrain, or maybe even some of the parts in the gearbox, but we'll give it a go and see. That's as much as I have time for today. We'll probably take this up with the 2 servos in the next video. It'll probably be getting, well, some sort of a hinge pin for this rear link and connecting that servo up, and then one for the steering servo. Steering, we have 3D printed parts there for that, so should just be a matter of connecting from there over to a servo here somewhere probably. And then after that we'll just have the wiring left to do, so we'll probably add a lot of lights to the cab of this because it's such a big vehicle. I think it'd look pretty cool if we had like 6 straw hat LEDs on the top there. It's the same on the front, 2 on the front. And you have a few extras down here as well maybe, and there's another one. There's a lot of place you could put LEDs on this, and I think the big straw hat ones would look pretty good. So that's it for today. I hope you enjoyed the video. Make sure and hit the like button if you did, and get subscribed and all that. But that's as far as I'm going today, so thanks very much for watching.